In this video, I wanted to highlight at least one probabilities. This is kind of a small topic, but these probabilities are a little bit tricky to compute, so I wanted to look at the technique that we want to use here. So here's an example. There are 8 multiple choice questions on a test. Each one has 4 choices. If you were guessing randomly on all of the questions, so each one is equally likely, what is the probability of getting at least one correct? So at least one correct means that you could get 1 correct and all the rest wrong. You could get 2 correct and all the rest wrong, 3 correct, 4 correct, all the way up until 8 correct, right, if you got them all right. Well, this is a fair amount of choices already, but if you think about each one of these categories, getting 1 problem correct and all the rest wrong, well, you could get the first problem right, but all the rest wrong. Or you could get the second one right and all the rest wrong, or the third one right, etc. So since there are 8 questions, there would be 8 possible ways to get exactly 1 correct. Now if you get 2 correct, this gets a little bit more complicated, right? You might get the first 2 right, or you might get the first one and the third one right, or say the second one and the 5th one right. We'd have to come up with a good method of listing them all out, but this would be a whole lot of different options. And it only gets worse as we go towards more problems right. So there's really a lot going on here, and it's going to be really difficult to keep everything straight. This is not the way we want to compute an at least one probability. The way we want to set this up is by saying, okay, at least one correct, it'll be a lot easier to think about the complement of this event. So remember, the probability of a complement, the probability that this doesn't happen, is 1 minus. So here we're looking at least 1 correct. The opposite of that would be none correct, or the probability that all of them are wrong. So we're doing 1 minus the probability that we didn't get any correct at all, or 0 correct. Now this is a lot easier to compute because there's only one way to get them all wrong. Every single question is wrong. Now just on the side here, if we're talking about one question, the probability that we get it right versus the probability that we get it wrong just has to do with how many choices we had. In this problem, it said that each multiple choice question had 4 choices, which means that the probability of getting it right if you're just guessing would be 1 out of 4. The probability of getting it wrong would be 3 out of 4. Now this is just for one question. So if we come back to this and say, okay, 1 minus the probability that every single question is wrong, this is really an AND probability. You might want to look back at the AND probabilities. This is the probability that the first one is wrong, and then the second one is wrong, the third one is wrong, etc. And since these are all independent events, we're multiplying their probabilities together. Now the probability of getting it wrong is 3/4. So this would be really 3/4 times 3/4 times 3/4 times 3/4, right, for all 8 questions. But I don't want to write it out like that, so I'll do our 3/4 to the 8th power. Now if you compute this out, this is about 0.1001 if you round to 4 decimal places here, right? This represents the probability that you would get every single question wrong, right? This is about 10% chance that all of the questions would come out wrong, which is not great. We want to do that 1 minus to get the probability that we want, and we get 0.8999, again rounded to 4 decimal places here. So this means that the probability of getting at least one answer correct would be close to almost 90% here. A little challenge, you can think about this. What about if we wanted the probability of at least 2 correct? We'll do this in the same way, but this is a little bit more complicated, so you might want to try this one out if you're up for something a little more challenging. Okay, to finish off the video here, here's a problem for you to try. This is going to be an at least one probability, which you should know since that's what this video is about, but notice that our problem is asking about at least one of your friends having an accident. And here's a little follow-up question down here as well about whether this is really reasonable. That's it for this video. See you next time.